Hi everyone, in this video we will learn about Gradle in Android development and see the roles of Gradle in Android. Then, in the Android project, what is the structure of Gradle build files? Then, we will learn in detail the content of these files and see how these work in Android to build our application. Okay, we move to the next slide to see the roles of Gradle in Android. Gradle is the official build system for Android app development. It is a powerful automation tool used for compiling, testing, and packaging Android applications. Gradle provides a flexible and customizable build process, allowing developers to define how their projects are built and deployed. The first role of Gradle in Android is the build process automation. Gradle automates the entire build process, from compiling Java Kotlin code to packaging the final APK AAB file. Gradle follows a three-phase build process: initialization phase, configuration phase, execution phase. In the initialization phase, Gradle determines which project's modules are involved in the build and loads settings from settings.gradle file. In the configuration phase, Gradle reads build.gradle files to configure tasks and create a task graph for requested tasks. Then it applies plugins and dependencies. In the execution phase, Gradle runs tasks in the correct order and builds, compiles, and packages the app. One of the next roles of Gradle in Android is dependency management. Gradle allows easy integration of external libraries through repositories like Maven and JCenter. It allows developers to declare, download, resolve conflicts between different versions of dependencies, and manage external libraries seamlessly. The next role of Gradle in Android is multi-flavors and build variants. Gradle allows you to create multiple build variants in an Android project by combining build types and product flavors. This allows the creation of different versions of the same app, e.g., free vs. pro, staging vs. production, efficiently for different use cases. The next one is resource and code optimization. Gradle helps optimize both resources, images, layouts, assets, and code, Java Kotlin, dependencies, to reduce app size and improve performance. For code optimization, there are some main techniques such as code shrinking, removing unused code, code obfuscation, enhancing security, and code optimization, inlining, and dead code removal. For code shrinking, Gradle uses R8, default since Android Studio 3.4. and previously ProGuard to remove unused classes, methods, and fields. Also, to inline functions and simplify expressions for better performance. And also to shrink the bytecode to reduce APK AAB size. For code obfuscation, Gradle renames classes, methods, and variables to make it difficult for attackers to reverse engineer the app. For code optimization and inlining, Gradle moves frequently used function calls directly into the calling location. For dead code elimination, Gradle removes unreachable code and unnecessary branches. Next, resource optimization has some main techniques, such as removing unused resources, resizing and compressing resources, removing unused translations, and enable resource compression. For removing unused resources, Gradle can automatically remove unused images, layouts, and other assets. For resizing and compressing resources, we can use WebP format instead of PNG JPEG to reduce image size without quality loss. Convert PNGs to WebP. Android Studio provides a built-in tool. Right-click image, convert to WebP, and use vector drawables instead of raster images when possible. SVG-based vector images scale well across all screen sizes and reduce the APK size as a single vector replaces multiple resolutions, HDPI, MDPI, XHDPI. For removing unused translations, if our app supports multiple languages but doesn't use certain translations, then we can remove them. For enable resource compression, compressing resources like XML and assets reduces app size. For example, PNG optimization. Use tools like TinyPNG before adding images, and font optimization. Include only the necessary font styles. Besides that about optimization, Gradle also has APK and AAB optimization and dependency optimization. For APK and AAB optimization, Gradle can split APKs by density and ABI. Instead of bundling all resources in a single APK, Gradle can generate multiple APKs per device configuration. The benefit is to reduce APK size by generating device-specific versions. We can also use Android App Bundles, AAB. Google Play recommends AAB, Android App Bundle, which optimizes APK delivery by delivering only necessary resources per device and reducing APK size by 30 to 40%. For dependency optimization, Gradle can remove unused dependencies. Gradle dependencies can significantly impact build time and APK size. Remove unnecessary ones from build.gradle file. Or Gradle allows developers to use dynamic feature modules. For large apps, break functionalities into dynamic feature modules instead of including all features in the base APK. The benefit is users download only the necessary modules, reducing install size. We can also enable dependency caching and Gradle caching to prevent downloading dependencies repeatedly. This speeds up builds and saves bandwidth. One of the next roles of Gradle is multi-module project support. Gradle supports multi-module projects in Android, allowing developers to break their apps into multiple independent modules. This improves code organization, build performance, reusability, and maintainability. A multi-module project divides an Android application into multiple modules instead of a single monolithic module. Modules can be app module, app, it's the main entry point of the application. Library modules, library, it's reusable code like UI components, networking, database logic, etc. Feature modules, feature XYZ, it's independent features that can be loaded dynamically for dynamic delivery. Shared modules, core utils, it contains shared logic, e.g. API handling, utilities, models. And the next role of Gradle is custom build tasks. Gradle allows you to define custom build tasks to automate specific actions such as file processing, generating reports, or modifying resources. These tasks can be written in Groovy or Kotlin DSL inside the build.gradle file or build.gradle.kts file. Finally, we will see the last role of Gradle is continuous integration, CI/CD. Gradle plays a crucial role in continuous integration, CI, and continuous deployment, CD, pipelines for Android apps. It helps automate building, testing, and deploying apps efficiently. Continuous integration, CI, automates code integration, builds, and tests on every commit or pull request. Continuous deployment, CD, automates AP/AAB generation, signing, and publishing to Play Store or testing platforms. Some popular CI/CD tools for Android using Gradle, such as GitHub Actions, GitLab CI/CD, Bitrise, Jenkins, CircleCI, Azure DevOps. The benefits of CI/CD with Gradle are automated builds, no need for manual APK builds, and faster testing. Unit UI tests run automatically, and early bug detection, catch issues before deployment, and secure code signing, uses environment variables for key store credentials, and also seamless deployment, auto-upload to Google Play or Firebase app distribution. Okay, all right, we have seen the main roles of Gradle in Android, a little bit long and a lot of theory knowledge, but I really want to tell you to have a general picture of Gradle in Android, and then we will go to discover in detail later when we have already experiences in Android in general and Gradle in particular. Yep, so see you in the next lecture.